Welcome to Verify and Secure. So what's the goal of this session? Very simple. It's to articulate GitLab Verify and Secure functionality better so that you can have more effective sales conversations. That's kind of the theme of every single session that I put out. It's so you can guess what the goal of every session is. So what's our plan for doing this? I want to show off the technical things behind this. So I think that a lot of times when we hear someone present, they'll talk about all of the terminology and stuff like that, but unless you like actually see it, it can be hard to understand. So I set up basically a bunch of sandbox environments in which I can show how this stuff works. It's not going to get too technical, but it's just to explain like, and when we're talking about code quality or linting or like, unit tests, this is what this actually is, right? And the whole goal of this is that once you can see it, then hopefully you can articulate it with more confidence. Yeah, and so that ties back into seeing all this stuff in action in GitLab. We'll explain the abstract principles of what is a unit test, what's an integration test, and then we'll also see how GitLab does all this stuff so that ultimately you can have a better sales conversation. That's the entire goal. So what have we discussed so far? 10 product stages, very deep product. We've talked about plan and create, and what we're talking about today is these two stages. Before I jump in, I know that some of y'all have been here for a long time, so standard disclaimer always applies. If this is something that you've already heard of or you want to hear something more, just let me know and interrupt me. Make this conversation your own. All right, so this is something that I think is really important for us to understand. Yes, it is absolutely true that we have 10 product stages, but for command of the message, the top 3 things on the actual sheet all have to do with verify and secure. It really literally is like intrinsic to our value proposition. So yes, one tool for the entire DevOps lifecycle, that is true, but in actuality, people really only care mostly about 4 of these product stages. So they care about issues, SCM, CI, and security. That is like almost every single conversation I've ever been on. And so I think it's really important to just sort of like lead with our strength of like, those are our 4 things. Yes, you get all this other stuff, but this is where we shine, right? This is our fundamental value proposition. Why is this so important is that this is our unique differentiator, right? And I'm gonna actually build out sessions for all of these different product categories, but I just wanna let you know that like, as an engineer, we have all this other stuff, configure, monitor, defend, and I've spoke to a bunch of different engineers in the company, and other engineers advise, and we don't even use some of this stuff for our own things. In other words, we use what Amazon Cloud or Google Cloud actually provides for releasing all the time. And so that just goes back to the fact that like, this is our maturity chart, right? Some of these have a heart in front of them, and some of these have circles. Which ones have circles and heart? SCM does, CI does, security is half, but we're still better than a lot of other people. So these are relative strengths. Some of these other ones are just not as mature. So yeah, and understanding CI and security is really functional, really important because of this. This is the thing that like we are best at, right? So SCM and plan, just to put this into perspective, yeah, do we have differentiators? Absolutely, right? But if you look at all these tape measures, if you just imagine someone going into a store, like the number 1 thing that they're really thinking about is like brand, and then number 2, price, right? Like, if it's some knockoff brand I've never heard of, I probably don't want to get it. But if one's like, I just generally want the cheapest option. And as someone who's been on the other side of the fence, who's like selected tools before, like there are certain things that, yeah, so I'll just give you an example of this. So type into Google like best project management software. So this is our issue tracking stuff, right? And then you get this list of like 40 best project management tools. You never want to be one vendor among a list of 40, right? It's a crowded market. But if we stick to the fact of our unique differentiators, which is that we're one tool for the entire DevOps lifecycle, you get integrated SCM, CI, and security, then that's where we really shine. And that's something that no one else really does right now. So diving into verify, and really understanding what this is. So imagine you're writing a book. I think that a lot of people here have written long papers before, and imagine writing it without spelling and grammar checker. So fast forward or rewind like 100 years ago, no computers. You write some really big manuscript and then you hand it into an editor. Probably a large chunk of what the editor does is to just correct your writing and grammar, right? And then you get it back like maybe a month later. You have to go edit it a bunch. Then you iterate and go back and forth like 5, 6 times before the editor is finally happy with it. And then that entire process might take like half a year if each time you go back and forth, it takes 1 month. So this is super time intensive, right? Now let's just change this situation. So now imagine you had an automated spelling/grammar checker. How would this speed up your project? So now you're writing on Google Word, all of the things that don't make sense and spelling stuff, you can just right click and change. So, like the version that you hand the editor now is going to be way higher quality. And ultimately, this is going to speed up this entire editing process. So ultimately, what the verify stage gives you is automated quality checks for software. That's what it does. So once again, all of software is just a bunch of text files. That's something that we need to keep back to. So it's like Netflix, Amazon, Hulu, GitLab. Fundamentally, all of these things is just a bunch of text files. And so like this sort of syntax checking and spell checking, this analogy actually applies way more than, it's not just some sort of hackneyed like analogy that's a stretch. It actually literally what it's doing is it's checking what's, if the stuff that you're saying syntaxically makes sense. And this allows you to write better software quicker, right? Which is our fundamental value proposition. So quick reminder on Agile. So like Agile is this thing that we hear about a lot, right? Imagine you're building a house, and so you come up like one way in which you could do it is you write up this like 10-page document to the builder, and you say, I want 3 bedrooms, I want the bedrooms here, I want granite countertops, all this stuff, A, B, and C, and then you left and you came back 6 months later. So the big problem with this is that there's always room for interpretation for any sort of set of requirements. And inevitably what happens is that the builder is going to misinterpret some stuff, or your requirements weren't completely clear, right? And then so one room might be built where you didn't expect it, or the painter might be using like a different color than what you expected. And then so what happens now is that you have to fix things at the end when it's most expensive. So if you had to move one room out all the way at the end, then that would involve ripping out a lot of other stuff from the house. It is most expensive to fix any project at the end. And so just going back into history, software engineering was really started taking off around 1970. And the first way in which we made software was exactly like this. You had people come in, give a list of requirements for a website or something like that, come back 6 months later, and then you handed him, your basically like your finished product. And then there would always be misinterpretation, and you had to iterate when it was most expensive. So that's the waterfall way of developing software. Agile is the newer way of developing software in which you iterate, right? So the whole idea is now I lay the foundation, and then the builder basically says, come back. Is this how you like it? There's something that you want to change? Great. So now we change it like at that point in time in which it's really easy to change, right? And then so then I build the scaffolding. Hey, do you like it? Then I start putting in some of like, the piping. Hey, do you like it? And then so the whole idea is you have tests all throughout the process, and you can correct things when it's least expensive to change. So some of this terminology, I think it's really important to use the terminology correct. If I think that engineers are generally like, they're very, very peculiar to the terminology that you use, in a sense that like if you use some of these terms a little bit incorrectly, then it triggers off an alarm in their mind. So it is important to go over what some of these terms mean, right? So Agile and Agile is like, and Waterfall, they're just sort of like philosophies, just like, hey, we should have voting, or like we should have social justice as a philosophy, right? But behind every philosophy, you actually need some plan to implement this. So how you implement Agile, which is a set of principles, is that you engage in what we call CI/CD, which is a bunch of engineering rules. So the whole idea is Agile's principles. We want more communication. We want iteration. We value cross-team collaboration. And CI/CD is how you do it. So how do you do it? You merge your merge requests very quickly. You continuously deploy stuff into production. So it's like where the rubber actually meets the road. And then, why does this impact a business? Why does this matter to every single person that we talk to? Is that if your development team with a mature Agile implementation using best CI/CD tools, you're probably maybe 10 times more effective than people who don't have any of this stuff. Is that, and I know that that's sort of like one of these things that you hear and you kind of raises the eyebrow a little bit, but I've talked with people like all across the country for years, back when I was at Red Hat and I was doing sales consulting. And I do actually think that this is true. That's why I wrote it. So I've talked with teams at Microsoft and Google that they're literally like deploying like 30 times per day. And I've also talked with like a lot older, like either finance legacy systems, and they deploy like once a year, right? So huge difference in industry. So everyone wants this, but it's hard to implement this. The whole value prop of GitLab is that it makes implementing Agile easy. So it's one tool. The fact that everything is one tool for the entire DevOps lifecycle and all the automation that we include in, this is our basic value prop. Our customers want Agile, they want CI/CD. GitLab makes this easy. We are one of the best companies out there for this. Benefits of Agile: instead of going down the wrong path, walking 5 miles down the wrong road, and then having to go back, when you're continually iterating and checking on where you are and things like that, then if you go off track, you can find out sooner and then course correct, when saving yourself a bunch of time. The businesses want Agile because they want to have more effective engineering teams, because they want to remain competitive. All right, so how's all this work? It works because we include lots of automation that fundamentally saves our customers a lot of time. So like, as you can imagine, just from a sheer work perspective, like workflow perspective, it's a lot easier for a builder, in our house analogy, to get a 30-page document, go out, build an entire thing, because you don't have meetings, you don't have check-ins, you don't have quality control throughout. You'll pay for it in the long run, but in the actual work process itself, it's a lot more simple, right? It's just, you get this document, you build your house, you're theoretically done until you have to correct a bunch of stuff. Agile is a lot more complicated. Agile, you have to have all of these check-ins, you have to have cross-team collaboration, you have to go find out who your stakeholders are, you have to go communicate with them, you have to have a lot more meetings. And so on the surface, implementing Agile requires a lot more work. This is why most people are unsuccessful at implementing Agile. And so how do we allow people to do this easily? Well, I'll show you this in a couple of slides, but what people get out of it is saving time and money, eliminating human error, and actually implementing Agile in a way that provides value to your organization. So let's show off how this works in a demo. Here's GitLab. I'm an engineer. I get an issue. This issue is to like create some sort of new button or something like that. After I go work on this, I spend a week on it. I create my merge request. This merge request is going to solve this issue, and that's how I get credit, and that's why I get paid. So here's some merge requests that come in. And one of the things that happens with all these merge requests is that all of our CI runs in the background in an automated fashion. No one has to go in, click a button. No one has to go in and, like, everything's automated. And if you just think about like the power of automation and saving people time, it's the exact same value proposition with our CI. So here's the merge request that comes in. The changes that are, these are the changes that are being proposed. It's all this green text on the right. And that's how the engineer gets paid, right? And so over here, you can see that there is this tab called pipelines. if I click on this pipelines view, I get all of this stuff that happened in an automated fashion, like completely for free. And the main thing that I want to show y'all over here is the number of tests that have been run. There are over 100,000 tests that have been run because as part of this CI, and just like how, like in our Google document, like word analogy, just sort of like, hey, we're testing for spelling, we're testing for grammar, we're testing for all of this other stuff. There are literally there are 127,000 things that we are testing for as part of our CI. So that's basically going to very, very powerfully make sure that our software project stays on track. What are some of the things that we test for? We test for code quality. We'll talk what that is. We'll talk about dependency scanning, security, stuff like that. But I love showing this chart when I'm doing demos because most people and our customers that we speak to, they probably have maybe 1/3 of this, maybe a quarter of it. And it's just sort of like really visualize like, hey, you get all of this in automated fashion, requires zero extra work on your, and you just have to set up GitLab. It's a really powerful visual for demonstrating GitLab value. So that's GitLab. Let's talk about software tests now, because that's something that I just showed. So what's that 127,000 software tests? What does that actually mean? So just like an example of like this house, there's a lot of things that we need to make sure that, if we're gonna like test this house and make sure that we're doing a good job, right? So a lot of these are gonna come from, the guidelines for housing. You have to have a certain number of fire alarms. You have to make sure that like, your water heater is a certain number of inches above the ground, right? And then so if you can just imagine you extending this analogy, imagine if like, instead of having one person going around checking if you have enough fire alarms, if your piping's all screwed on correctly, if that were all being done in an automated fashion. So if you had a robot that was just going around the house and doing all of that for you, right? So there's a lot of different types of software tests. This is what they call a test pyramid. In my story, I was a test engineer for about half a decade. So this is basically what I did all day. Your unit tests are basically your smallest tests. And then you have these things called integration tests and end-to-end tests. So an example of like a GUI test or graphical user interfaces, that's really do our buttons work. I'm gonna write some sort of automated thing that's gonna click on all of our buttons. Does it take me to the right screen? If I log out, does that like take me to the right screen? Can I like hijack this website if I like try to log in 5,000 times quickly, right? End-to-end tests, that's like, if I turn my computer off 500 times, turn it back on, then does the server like restart? Does it have any problems with that? Unit tests, I'll show you a little bit about in a second. So here's a actual, how I got hired as an engineer is I didn't go to school for engineering. I had to basically code a bunch of stuff on my own, and then that's how I proved to my future employer that like I could code. So this is one of the things that I actually built. This is the game of chess from like, a Python perspective. And so I just like wrote all this stuff, showed people that I could code. That's how I got a job. Over here, there's this file that's test.py. This is where all of their tests live. So tests in general aren't something that you get for free. Some of the tests that you get with GitLab, they are for free. But in general, you have to write all of your tests. So examples of tests that you could write with this chess game is, can my pawn move forward 1 space? Can it move forward 2 spaces, right? What happens if I try to move it 3 spaces? Then it shouldn't work, right? What happens if I try to move it 20 spaces forward? Well, that's off the board, it shouldn't work. And so how software tests actually work is that you write out all of these unit cases, and then you basically run all of these automated checks that happen every time you're trying to submit a merge request to make sure that nothing broke. And so we can actually see some of the tests that are over here. So this first test is verifying if I can move pieces in some sort of expected way. What are some of the things that we're testing? One thing is, can I move my pawn forward 1 space? right? Rook, that's like the castles. Can I move it forward several spaces? And then we have to do like the exact opposite. So we have to check if things are illegal, right? So what happens if we try to move a pawn forward 3 spaces? Well, it shouldn't work, right? And so on and so forth. How all of this stuff like actually looks like if we were to run it is, so over here I have my chess, I have like my chess like game, and if I just like run everything, then it runs through all my tests. As you can see, that took 0.03 seconds, and all 31 tests passed because I didn't do anything. It created a bunch of virtual boards, and then it tried to see if like things made sense. And that's fundamentally what all the software tests are doing. So over here, I had a, like the knight or horse. Did it move over here successfully? Well, it did. So, like we're happy about that, and our test checked. So like going back to what GitLab is doing, and just sort of like bringing everything home.
Hey, Chris, could I ask a quick question on that?
Yeah, absolutely.
You said that GitLab supplies some tests, but obviously you have to create most of your own. Are we talking like templates for certain functions that you're trying to run, and is that universal across different solutions that you might find on the marketplace, or is that unique to GitLab?
Yeah, that's a really great question. Let me go more into detail about that. So if you just think about the wide variety of software projects that are being housed on GitLab, right? So a bunch of our customers are fundamentally designing websites. Maybe someone's designing a database. There's all sorts of weird stuff that people use GitLab for, right? So some people are housing like, I don't even need to articulate that to y'all. Like y'all talk to customers more than I do. So we cannot supply tests that are universal to every software application out there. And every engineering team, as they develop a software application, they are writing the tests themselves. So let me give you an example of that. I'm designing some website. I create a bunch of buttons. Now, as I am creating these buttons, generally what I am doing is I am also writing some automated test that if I click on this button, then the right thing happens. And that's how it's almost like I build something, now I build a test. I build something new, now I build a test. And that's just what I keep on doing throughout the entire development process. So there's no way that GitLab can build all of those for you just because we don't know what your application is. And just as an analogy for our housing analogy, like I can't, like, there's no one building template for it. There are things that are universal to every building, right? Every building needs fire alarms. Every building, needs to have a water heater that's a certain number of like inches off like the ground or something like that. So those are universal tests. Those are things that we give you as part of GitLab for free. But in terms of actually like testing your application itself, because we don't know what your application is fundamentally, people have to build additional tests on top of that. And that's what your unit tests and your end-to-end tests are.
Thank you.
Yeah, let's talk about some of those universal tests. I want to continue clarifying some of that stuff. So universal test number 1, this is what we call code quality. That's something that we get asked about from time to time. So fundamentally, all software is text files. And as someone who's been on a software team for like a really long time, I can tell you that there's always going to be the one person on the team that just like writes like really, really, really long sentences or things that is just sort of like, it makes it really confusing for everyone else. And then so just like how there's like the MLA guideline or Chicago guideline for writing essays, there's actually style guidelines for coding in every coding language. So for Python, there's this thing called PEP8, but every single programming language has style guidelines. And this literally says like, like things over here. How many times should you indent? Should I use tabs or spaces? So it's just like really, really, really like granular things that you need to pay attention to. Does this actually matter? It actually matters a huge deal. Because otherwise, like the one person who writes like crazy stuff is going to end up like making confusing everyone. So something else, review applications. In the merge request view, over here, I can see what this text change is, but there's a big problem because for solutions like GitHub and Bitbucket, then all I get to see is the proposed code change. But the big problem with this is that it's hard for me to visualize what this code change is actually doing. Like I can look at what this is doing somewhat, and if I'm a great engineer, I can know if it's good or not. But until I actually see that button, or if I can see that chart that this is corresponds to, like it's still me guessing, right? And so what a review application is as opposed to just seeing this stuff, you actually get a new version of your application that's running all the latest code. So as opposed to me guessing what that change does, I can see the new button that this change is corresponding to. The whole value add for a business as to why they want review applications is that it speeds up the peer review process. So all of these merge requests come in. It's a lot of times it's really hard to understand what this stuff is. And then so sometimes the merge requests wait. But if I can just like create a new version of my application that's running somewhere with all these changes in, I can speed up the process of merging and evaluating these changes. And that fundamentally just makes one of our fundamental value props is develop better software faster. So this is an example of how we can speed up the entire development process. How powerful is this? If people are using Kubernetes, it's very powerful. It's actually a huge, huge deal, these review applications. All right, so that's verify and secure. I hope that helped. Now let's talk about reducing security and compliance risk. Security. This is something that I think is really, really, really important to understand. I think that one of the things that I told y'all before is that software teams generally don't like each other. So I was in a test team. The developers did not like me. As a matter of fact, sometimes they went out of their way to be really nasty to the people on my team. That's very common. Generally, developers also don't like security people, and security is almost like one of those things where it's like, we know that we should be doing it, but we don't. It's almost like the United States understands that we should be polluting less, but like we just never really like put that much effort into it for whatever reason. Not trying to get too political. But yeah, so GitLab's special in that we offer security scanning as part of the development process through our CI. We have to understand what the before state is. The before state, before GitLab, is generally, and this is especially true for SMB and commercial, is that they don't have enough money for dedicated security people, right? And so what they do is they go develop all their stuff, security is this afterthought, and then it's the same problem with that house analogy that I thought I've been mentioning before. So it's like, because we're checking security all the way at the end, if we find any problems, we find them when they are most expensive to fix. And that's an example of, how we're not doing things as efficiently as possible. So SMB, typically what they do is, even if they have enough money to do this, they hire out contractors to do this. These contractors get paid $300 an hour or something exorbitant. And so the value that we offer is that it's several fold. One, a lot of people can save money. So the SMB people, they don't have to hire out for all these contractors. The enterprise people, we can complement their existing tools. Sometimes you can eliminate some of those tools. In general, for enterprise, we like to integrate with whatever the rest of their stuff has. That's like a generally accepted sales motion among the sales that I talk to. And then so save money. The other thing is that we can speed stuff up, right? So as opposed to testing security all the way at the end, if I'm testing security in the testing process itself, this allows me to find problems sooner, which allows me to course correct sooner. So our fundamental value proposition of developing better software faster. That's how we do it. We'll talk about shifting left in a bit. Can I clear anything on verify or security that I've mentioned so far? Sounds good. We'll continue then. So merge request, people collaborate, people are going back and forth. GitLab also improves the quality of the collaboration that we have. So as opposed to a typical solution like GitHub, where all of your developers are on it, because all of these different teams, your test people, your security people can be on GitLab, then, if a developer is creating something and they're going to merge something in that's going to negatively impact the rest of the product, then all of a sudden our security people can chime in. How much does this matter? It actually matters a lot. I'll give you an example of how this would matter. So a lot of times, like, a developer will choose to use something like Django 2.1, and they'll, create a merge request, start using Django 2.1, and then unbeknownst to him, Django 2.1 actually has, some sort of like security vulnerability or something wrong with it. And then, so just continuing the story. So the developers now writing all this code with Django 2.1, writing hundreds of files, thousands of lines of code, all using Django 2.1. Finally, the development process is done. Security takes a look at it, and then security realizes, dang, you use Django 2.1? You can't use Django 2.1. It doesn't pass our security compliance stuff. And so now this developer needs to edit that 100 files that he just wrote in the last 2 months. Versus, like, you could catch it all the way in the beginning with GitLab, because all of your different teams are looking at the same stuff. We have better cross-team collaboration because everyone's on the same platform with GitLab. It's the same concept of silos. We hear about silos a lot. Silos are actually a really, really big deal. And once you break down your silos and you have better cross-team collaboration, you have way faster moving software projects. GitLab's one shared table, right? So I've definitely shown you all this picture before, but typically your developers are talking about their stuff, your securities are talking about different stuff, but by having one big table, everyone knows what everyone else is doing, and that's one of the fundamental value props of GitLab. Security contracting, as you can see over here, I actually think that this is like a medium grade engineer for this. The advanced grade engineer, especially with top secret clearance, they make well north of this. And when they're working as a contractor, this is when these SMB companies get, shell out like thousands and thousands of dollars for contractors that are, and the idea is that GitLab can replace a lot of this, especially in the SMB space. So let's talk about, some of the things that we actually do. So it's really important to understand some of these things on a high level. SAST and DAST, the important thing to know about this is that these are complementary. It's just like, just trying to think about this. Like, if you have salsa without chips, no one really wants to eat chips by themselves. If you have salsa by itself, people definitely don't want to eat salsa by itself. So these are complementary. SAST is like 85% the value. DAST is 15%, but you're incomplete with just one of these categories. If some of our customers, if they have anything, they have SAST. So let's talk about what these actually are. SAST is static application security testing. And what I mean by this is it doesn't know your application. Literally what it does is it looks at your code, and then it looks for vulnerabilities in your code itself. So like, here's all of these chunks of code. It'll run like stuff through this code to try to break it. And that's fundamentally what SAST is trying to do. DAST, however, needs a live version of your application running, so that, and then what it does is after there's a live version of your application, it's going to bang on it, right? So it's going to turn your application on and off 5,000 times and then see if like it like falls over, and if I can like break into it. If I like try to log in, like, wow, that's happening or something like that. There's all sorts of obscure stuff that DAST does to try to break into your website. Other things is like, here's this login form, right? I used to actually design login forms and test these. So it's expecting two things, right? So a username and password. What happens if I log in to the same set of credentials using like 5 different browser sessions at the same time, right? So it's like I have different Chrome sessions and I try to log in using the same username and password. Can I break it? Like, sometimes you can. What happens if I put the password section blank? Or what happens if I like inject some sort of like JSON or something into these fields? I'll show you what that means in a second. But yeah, so the difference is SAS just looks at your code, tries to break it. There's no running version of your application. Dash, you have a running version of your application, and then it's gonna basically try to like bang on it and try to like make it fall over, and so that you to see if like you can get user data or something like that.
I have a
Container
question.
scanning. Yep. What's up?
Sorry. I'm asking about the dynamic testing. Is it more like a sandbox type of environment when it's doing that, or is it running live?
It'll be a sandbox version.
Okay.
For sure. Thanks for asking. All right, so container scanning. This matters a lot, and most people don't know about how important this is. They might have some understanding of how important this is, but in general, it's just sort of like it's like our global response to like global warming. It's like people know we should care about it, but like people don't put enough effort into it. Okay, so basically what people do with containerized applications, and this is what the vast majority of businesses do, is they go on this one website called Docker Hub, and then they download stuff that they want. So if they want like a MySQL database, they want a web server, whatever, they'll go over here, then they'll literally just like download it and start using it. The big problem, and then we can just check out like how many different, how popular some of these are, right? This has been downloaded over 10 million times. Postgres, another database, downloaded over 10 million times. If I see all the official images, I have to scroll all the way down. If I keep on scrolling down, WordPress, very popular application, downloaded over 10 million times. So this is being used very, very, very heavily by businesses around the world. Now, the big problem with this is that anyone can upload stuff onto Docker Hub. And people do upload whatever they want onto Docker Hub. So that's problem number one, is that people are getting stuff that's, you just don't know if you can trust it or not. So what GitLab does is it basically scans whether your containers are trustworthy or not. So over here, I'll give you an example of this. Going back to Docker Hub, I forget which tab it is. It's this one. All right, so MongoDB, this is a database, right? And there's all sorts of different versions of this, right? So like version 3.6, version 4.0.20, whatever. And then it knows whether or not these versions are safe, right? And then so it will scan your container, identify it, find out which version it is, and it'll let you know which ones are safe and which ones are not. The vast majority of containers that are being used by businesses in the world today are not safe. And most people are just getting stuff off of Docker Hub. It's a really, really big problem. And I actually think that this is going to be a huge market need in the future. There's no like great solution in that space right now. All right, so it just showed off Docker Hub, dependency scanning. So this is another thing that we do. Obviously, this image is not of a software application, it's of a car. Let's just use an analogy here. So in a car, you have a bunch of different parts, right? So you have wheels, you have your transmission, you have your engine, and then they all fit together. Just like how a car has many different parts, every single application that's being hosted on GitHub, so like a website, a database, whatever, there's a lot of different pieces to it too, right? So for a web application, you have a database, which is one component. You have like buttons, which is another component. You generally have an API, which is another component, and then they all fit together somehow. The problem is that like, just like how with a car, every once in a while, there's like some awful thing that they find out, airbags do not deploy, safety recall. If you have a Honda Accord 2009 through 2015, then bring it to your Honda dealership so we can fix this thing or whatever. Just like how there's safety recalls for car parts, there's problems with the individual components that you have. So if you are using Postgres as your database version 2.1, and then there's some awful security thing that's found out about it, then what you want to do is you want to update your Postgres version, and you want to be notified that this component has some vulnerability. That's what we do for our customers. When a customer like uploads all of like, GitLab's smart enough to find out what sort of components are in your application, and then it will let you know which components aren't safe. So if you're running some website, has components A, B, and C, C has some vulnerability, we'll tell you what that vulnerability is. So let me show you what this actually looks like. Here's GitLab. And as you can see, this is the GitLab code itself. And GitLab code actually has a bunch of vulnerabilities in it. Here are vulnerabilities. So we use this thing called Acorn 5.7.3. And what's the problem with it? The problem is, like we say the severity, how important is it? It's high severity. And what is this problem? Well, it's some technical thing, right? But an engineer would understand what this is. The other thing that we tell you is like, all right, Acorn 5.7.3, where did this dependency even come from? Well, we show you where it comes from. It comes from this file, right? So yarn.lock, and Acorn comes from here, right? So if I update this chunk, then all of a sudden version 5.7.3, if I were to bump this from 5.7.3, edit this text file, change it to something else, then GitLab is hypothetically more safe. And that's something that I'm sure our engineering teams are looking at right now. So just to recap, software applications are made of individual components. They are called dependencies. We are smart enough to let our customers know, one, what dependencies they're using and whether or not they're safe. This is GitLab code itself. We have all of these dependencies that aren't safe that we are using right now. One question that immediately comes to mind is like, why are we using dependencies that aren't safe? There's actually a lot of reasons why that's the case. And this is sort of like simplified answer is we're working on it. So we're not perfect. Fuzz testing. Fuzz testing is new. It's something that's a big deal, but it's really important to position this correctly because 90% of people that you speak to don't know what fuzz testing is. But if you talk to the right audiences and explain what fuzz testing is, they're going to be really interested in this. Why? Because you can, if you educate them, yeah, okay, so like we got to talk about what fuzz testing is first. Otherwise, it's just like, fuzz testing is basically this. This is Instagram. Here's the login site. And what I'm going to try to do as a hacker is I'm going to try to break into a site like Instagram by putting stuff that it's not expecting into these fields. So it's expecting a phone number, a username, or email, right? But what happens if I type in like a bunch of numbers? Or what happens if I type in like true, false, or like, some like binary stuff? So that's like kind of like a simplified example. A real example would be like if I were to do some like injection type of thing, .json, like, like something input thing, whatever, like whatever, python.lib thing, right? And then all of a sudden this runs and breaks the website and I get data out of it. There's all sorts of injections that you can use. There's MySQL injections. There's also command line injections. And fundamentally what these things are doing is inputting code where application isn't expecting it so that I can hijack your website. Very, very common. This happens. This is a really, really fundamentally like big security problem. So what's the value in fuzz testing? So there was actually a task group that did research on applications, and they found that injecting random stuff into your forms breaks around 1/4 of all of your applications. So not just in terms of getting customer data, you can actually break someone's website, crash their server, and like make things unresponsive if if it's expecting like a phone number and you put in like true, false, false, true, or something like that. Out of about 1/4 of all of the applications that were under this study. As someone who was working in engineering before, this is totally true. Around I had to basically do this, and I did this manually. So as opposed to having automation that does all this for you, what I did was I went into the website that I was using, and then I would type in like, well, what happens if like, I type in the wrong stuff. So like, what happens if I type in this? And it was very boring and monotonous to go through all these forms, typing in all of these things. And if I could have done it in an automated fashion, it would have really simplified my job and given me a lot of time back. That's something that GitLab does for people. So yeah, that's what fuzz testing is. Just to recap, fuzz testing is putting unexpected inputs into an application. So if it's expecting a username, you give like true, false, or like binary 0, 1, 1, 0, right? And this, if you're talking to like a test engineer or an engineering leader or someone security, they would definitely see the value of this. But we have to educate our customers on this because the vast majority of people do not know what fuzz testing is. All right, so now we got to talk about messaging. This is really important. Super important that we get this right. So first thing I want to talk about is DevSecOps, right? We've already talked about what DevSecOps is. So it's like, there's the idea of DevOps, throw in security in there. How do we do that? Well, you know, as opposed to just running CI and, you know, like testing stuff, now we also test for security. Therefore, we have DevSecOps, right? So as part of your DevOps like flow, you're also testing for security, therefore DevSecOps. Now, it's really important to understand how this term's received by industry. This term isn't widely adopted. So we have to take the approach that like most people don't know what DevSecOps is. The other thing is that if you're talking to a technical audience, I tell people to advise against using these like overly marketing terms. I'll explain why. And in general, the best practice is to avoid using these terms with technical people and introduce it as a new concept to people in leadership. So I'll explain why that's the case, but I want to show you why. So here's DevOps. Type into Google, how many results? 70 million, right? Lots of results. DevSecOps. Type into Google, how many results? 2 million. So we're talking about less than, we're talking about less than 5% the number of results as DevOps. So not widely adopted. Most people don't know about it. And now I want to show you basically, if you ever want to know what engineers think about something, go on Reddit. So I just want to show you something. Reddit article, 4 signs that demand for DevSecOps skills is growing. Blah, blah, here's an article, very clickbaity, probably put out by someone's marketing team. Now let's hear what the engineers are saying. W2F is going on with these titles. Let's go ahead and throw net in there as well instead of referencing it as DevSecNetOps, and we can just call it by the proper name of unicorn. I called this out the last time this abomination appeared. I pity anyone with this title. They're talking about people at DevSecOps and their job title. I really hate the term DevSecOps. Security shouldn't be in the way of dev and ops, blah, blah, whatever. And the whole point is that, all right, so I think it's really important to understand what is happening here. In our space and in technology companies in general, people want to be seen as an innovator. And if they prove that they're an innovator, and if the investors buy it, then all of a sudden they get these huge valuations, right? And then so in general, people want to make something new. So it's like, the problem with this is that people make all sorts of new terms all of the time. DevSecOps is an example of this. And so the real question is there substance or not? Engineers in general, they're very, very good on calling out the ones that don't actually have substance. And it's just sort of like, they can tell that it's like fluff. Do I think that the term DevSecOps is fluff? No, I don't, but I think that it's important to be cognizant of the fact that engineering people are peculiar about like new terms, unless it is something that has been substantiated by the engineering community. So let's just rewind. Marketing comes up with all of these terms, not engineers. And for someone who's in a technical background, it's very obvious when marketing has come up with some of these terms and then they reject them. So if we are to use these terms, we need to teach people about them. And we also need to understand that like some people are not going to be receptive of these terms. If it's a leader, like senior manager, director, VP, they may or may not have heard of this before. So we can seem as like a digital leader and educate them on these new trends in technology. That's fair. If I were talking to like an architect or, you know, a DevOps lead or something, I would probably avoid DevSecOps the term. It depends on the person, but as we've seen, DevSecOps has less than 5% the adoption as the term DevOps. So it's just like, that's like some of the nuances behind using the term. Now let's talk about shifting left. This is term number 2, right? So what's the concept of shifting left? So here's like the development life cycle, right? So we talk about requirements, then we develop something, then we test it, and then we deliver the product, and then we maintain and support it. Where's security into here? It's usually here. So it's not actually in this diagram, but part of stabilization is security testing. So the big problem with this development flow is because stabilization and security testing isn't part of the development process, it's like that house building analogy, right? So I build my house, all the development and building happens, I go away, now I test it, now I see if it's secure, when the cost to change this product to my organization is the most expensive, right? So the idea of shifting left is, as opposed to security testing here, we security test in the development process itself. So in this diagram, we have literally shifted security from over here to over here in the development process. So is this something that's powerful? Is this something that's real? Yes. Is it a term that was probably created by marketing? Probably. Do engineers think that this is the case? Probably. So yeah, I think that it's a new concept, the idea of shifting left. It really came out in the last, like, I'd say 12 months. Same caveats apply. It's a term created by marketing. What's the point of marketing? So that we can seem like a digital leader. And then the problem is that like everyone's doing this in our entire space. And then so the engineers, when they hear it, you know, their red flag goes off. Like you can only have so much like digital transformation, innovation things. The vast majority of like the terms that you hear are fads, and they don't even like, they will not, these terms would disappear in 6 months, right? So shifting left is not like a fad. It's something that is here to stay. But we have to be cognizant of the fact that engineering people, they're constantly hearing all these new terms. And the fact that a lot of people haven't heard of this before, if we talk to someone, never assume that they know what shifting left means. Instead, take an education approach where it's like, hey, let's talk about how you can speed up your development process. There's this principle of shifting left, and what that basically means is so on and so forth. And now you seem like a trusted advisor, which is the goal. All right, so just tying things up, we got to talk about some other stuff. This is just to help y'all in your conversations. So all of this automation and tests and everything, it has to run somewhere. You don't get it for free, right? And then so there's some server somewhere that's running all of the automation. That's what we call a GitLab runner. A GitLab runner is a server that like actually runs all the CI and stuff like that. How do you control how the CI happens? It's actually this one file called the GitLab CI YAML file. And so going back to my repo over here, GitLab ci.yaml file. So there's literally one file that determines all of the stuff that happens in my CI. Over here, you can see the stages: sync, prepare, build images. Over here, what's happening is sync, prepare, build images, right? So these are the first 3 stages. So this file determines what happens in our CI. And the really great thing about this is that I was a GitHub user for about half a decade. I was a Jenkins user for about 4 years. We are by far the most configurable right now. The fact that we can just like have one file in which you can put everything in and, you know, just edit everything over here, all of a sudden, you know, things are changed. This is really, really, really customizable and very, very intuitive for engineers to use. So it's really great. So that's the end of the presentation for, you know, Verify and Secure. I'd love to see if I can clarify anything to anyone. There is a homework that I'm going to send out. Please get it in by, you know, this Friday. And if people keep on asking me like, hey, can I have additional time or whatever? The answer is always yes. I'm not a stickler to it, but like, yeah, it's just trying to make sure that the messaging is like 100%. Can I help clarify anything with anyone? I know that was a ton of information, especially the security stuff.
So would you, if you were an SDR, would you, and I took a note and I actually went into my sequences immediately when you said that regarding DevSecOps being more of a marketing term than actually a term that would resonate with engineers that really know what's going on. If you were an SDR, would you remove DevSecOps from the type subject of an email? And the reason I'm asking that is, A, you brought it up, obviously, but also, I have had multiple conversations with a Sal who was pretty adamant about using DevSecOps in our messaging.
What space are you? Are you enterprise?
Yeah, name enterprise, yeah.
Okay. And is he talking to like director level and above?
More than likely.
Yeah, so I think that for his particular instance, coming in, introducing a new term, all of a sudden now we're the digital innovator and we're the leader, right? So we can use that term as that. We believe in DevSecOps. DevSecOps is this new thing that GitLab and other companies are pioneering. Our approach for it is X, Y, and Z. Let me show you about why you get stuff out of it. Now all of a sudden you're a digital innovator and you're a trusted advisor. So I think that for that space, that's fine. If I were doing outreach sequences to engineers in companies, I wouldn't use the term DevSecOps, just because like it does trigger off that like marketing fluff, like red flag trigger. I'd be really curious to see what the data shows. But at least like that one article that I found on Reddit. So let me talk about like my approach, right? Like obviously I think certain things, I need to make sure it's substantiated. So I actually typed it into Reddit and there was about like 7 or 8 articles that were basically saying the exact same thing out of the 8 that like appeared in the top. And the reason why I picked that one was because the other ones were using too many F-bombs in them and I wasn't going to put it into my slides. So like, I do think that is like a really, like, I mentioned it for a reason. Is that like a lot of technical people, they're inundated with all of like these new like technical jargon that comes from marketing. So I would say that like, yeah, your Sal's right. And I think your Sal's in his position for a reason, right? But I do think that like space persona definitely applies in terms of using this terminology.
Yeah.
So it's not just that it's a new term to them that would need definition to people who are below the director level. This is almost a pejorative term. This is something that they have a very strong reaction to.
Mm-hmm.
Well, the vast majority of people don't know what DevSecOps and shifting left is. If I guarantee you, like if I went to start texting like my engineering friends, hey, how many of you have heard of DevSecOps? Like I'd say maybe 10% of them have. Some of them would say that they've because they want to seem smart, but like most of them like haven't heard of the term before.
And it's not something that they would automatically know through osmosis. It's not self-defining.
No, it's not. Especially because engineers are so hyper specific focused on their individual stuff, right? So it's like shifting left, that comes from a project management point of view. You have your development phases, right? And so a developer is not even thinking that way in the first place. A developer is thinking, how do I get my buttons in so that I can get paid? A project manager may understand what shifting left is, from a security perspective, but like engineers aren't even like thinking about that whole timeline in the first place.
Well, I mean, that just from SDR perspective, because we're all SDRs here, it's so critical to what we do, because sometimes we are reaching out to below manager level. We want to reach out to the senior team leaders, the senior application developer type folks. We are doing that reach out at the same time we're reaching up, and really adhering to that persona and what they're really going to care about or more importantly, in this case, what's going to trigger them to say marketing shtick, delete, So it was really valuable insight.
Appreciate it. You can fact check me too. Type in DevSecOps under Reddit and then see what people think.
All right. Question about another feature, Kubernetes monitoring. Is that sort of under security and verify? Well, definitely not under verify, but how I know it's sort of part of security. So we didn't really get a touch on it. So I just kind of want to hear your thoughts on how that is a differentiator or not.
Yeah, that's a great question. Thanks for asking it. So monitor stage is covered in a different presentation. And if anyone's interested in learning more about monitoring, then just, I'm happy to do that. So, like the whole idea with monitoring is I'm a business, right? We talked about how if my website is slower, then that means that I get millions of less dollars if I'm some large like web service like Netflix. So that like absolutely matters to me. I need to have a good gauge in my environment. How does my environment fundamentally slow down is that I don't have enough servers that are running my environment, right? I think I'm answering your question, but what monitoring does is it gives you the charts that shows you like over here we have spikes at 9 every day, and then so it gives you the graphic visualization data so that engineers can like plan accordingly to the ebbs and flows and the usage of their web service or whatever application that they have.
And how does that tie to security? Are there instances where there's a huge load and that is like an easier time to be vulnerable for the services, or how does it affect security?
Yeah, I see them as like different things. So if there's a vulnerability to a web application, then you can do it if generally like the problem with security is that it's so vast, but in general, if there's some sort of vulnerability, you can take advantage of that vulnerability, whether or not one person's using the site or like 5,000 million people are using the site all at once. So the amount of web traffic generally does not make a web service less secure.
So in terms of like Kubernetes monitoring, is it only about performance, only about utilization and efficiency?
It can also be about cost savings too. So if you find out all your data in terms of performance, and then you find out that like, oh wait, we're actually have all these servers that are underutilized, and you can get rid of stuff as well. So I think that monitoring is the value add for a business for our monitoring software and capabilities is generally, do we have enough stuff? We don't want to have a performance problem. A performance problem is going to cost our business money, right? Number two is, can we save money, right? Do we have too much stuff? And then number three, I'd say is, it's really just those two. It's just making sure that like we are doing our part to make sure that we have like the best web service. So like if you imagine Hulu versus YouTube versus Netflix, if Netflix was really laggy, then in 1 year they wouldn't have any business. It'd go all to like Google, So it matters for a lot of these businesses.
Cool. Thanks for that.
All right. Well, happy Monday, everyone. Nothing like a good Monday morning session. I'll see y'all on see y'all around, and happy end of September. If I can do anything to help you all get SAOs, let me know.
Thanks, Chris.
It's great.
Thank you, Chris.
Take care.
Thank you.